It's time for Fun with Math, and today we're going to talk about the algebra of functions. What is the algebra of functions? And the idea is pretty simple. We're going to take a look at some examples involving tables, graphs, and formulas, and when we add, subtract, multiply, divide, and compose them. And that's the algebra of functions. So you have two functions like f and g, and we want to look at like f plus g, or f minus g, or maybe f times g, or you have f divided by g. And then finally, the one that you may be least familiar with is composition, which is f composed with g. And we'll talk about what that is in a little bit. But let's look at our first example here. So we want to take a look at a table, and we want to use the table to evaluate each function. And the trick to these problems is to write out what they're saying and then do what they say. So if you look at this, what we have is f plus 2, f plus g evaluated at 2. So we just write this out. What does this mean? This means do f of 2 and then add g of 2. And so once I know what this says, I'm going to do what it says. So it says go find f of 2. So up here, the input value is 2. And the output value is 5, so f of 2 is 5, so I'm going to write down 5. And then plus, it says find g of 2, and so here's g, here's 2, and its output value is negative 2, so plus and negative 2. And so that's really 5 minus 2, which is the number 3. And so my answer is 3. Let's do this one. So instead of plus, of course, we have minus, and so what does this mean? This means take f of 0 and take away g of 0. So what we have here is f minus g evaluated at 0 is equal to, and then what it says is f of 0 minus g of 0, and then we want to do what this says. So it says what happens when you plug in 0, what do you get out for f? So here's f, here's the 0 value, and so when you plug it in, it says you get out 0. So f of 0 is 0, minus, and then g of 0, well here's g, here's 0 again, and its output value is 2. So 0 minus 2. And so that's equal to negative 2. And so that's how we add and subtract functions when we use a table. The next example we're going to look at involves a graph. And so now we're going to use the graphs here to evaluate each of these functions. And in this case, we're multiplying, and then down here, we're dividing. So let's do what this says. This says take f times g evaluated at 0 is, and what it means, what it says, is do f of 0 times g of 0. And now we do what this says. So f of 0, the idea, the input value is 0. So here's 0 right here. We're going to look there. And we're not going to look at the red graph. We're going to look at the blue graph because it's f. So here's the output value there, which is negative 1. So f of 0 is negative 1. So I'll put in parentheses negative 1. And then g of 0. So for g of 0, again, we go find 0, and g is the red graph, and so the height above it's right here, the point above it's right here, and the height is 1. So it's negative 1 times 1, which of course is equal to negative 1. So my answer for this one is negative 1. And then I'm going to come down here and do f divided by g evaluated at negative 1, and so that's going to be equal to f of negative 1 on top divided by g of negative 1. So that's what this means. And then this says find f of negative 1. So I need to find negative 1 as an input value. So I go to the left, negative 1. F is the blue graph. So I'm going to come down here. Here's the point. And it has height, negative 2. And so on top, I'm going to put a negative 2 because that's the value of f evaluated at negative 1. Divided by, then g of negative 1. So I'm going to look at the red graph. Its point is right here. It has height 0. So it's negative 2 divided by 0. Oh, you can never divide by 0, so we say this is undefined. And a lot of times you'll see if I have something like this written, I'll put quotes around it because it doesn't really exist. So it's just sort of me thinking since it's not really a number. But you don't need to put quotes there if you don't want. But my answer is it's undefined. So that's how you handle multiplication and division when working with a graph. And then finally, we come to one of the harder ones, which is composition. And so let's talk a little bit about composition, because most of you guys are familiar with addition, subtraction, multiplication, and division, but composition, not as much. So the idea of composition is you have a function inside of another function. So when you write something, the definition, the way it looks like this, f composed with g, usually parentheses around it, of x. What this means, the way it's defined, basically what it says do this, f of, and I like to draw it really big, and then little g of x inside. That's what it means. And you can write f composed with g of x, or you can write g composed with f of x. And so this means instead of having f on the outside, of course, you're going to have g on the outside. And the order is the same. So g was first, g goes first. So g of, and then we write little f of x. So it's real clear what's on the inside and what's on the outside. So composition is important. There are lots of examples of composition. Usually the one I like to give you guys is if you go and get an auto loan. Both of us may be looking at the same car, it may be the same price, but our loans are probably different because when we go get our loan, my interest rate is probably different than your interest rate. So that our monthly payment, which depends upon our interest rate, is going to be different because it's really a composition of functions. It's composed with whatever interest rate we get. And mine may be lower or higher depending on maybe our credit scores or how much money we have for a down payment or whatever. But you kind of see it's like a function inside of a function. So here, let's take a look at this example. So let's just do what it says. So you have f of g of 7. So what it says is f of g of 7. So notice it's g of 7 little on the inside. And now I just do what it says. So what's g of 7? Well, here's the function g of x. Wherever I see x, I'm going to plug in 7. So this is really f of the square root. So wherever you see an x, you're going to put a 7. So square root of 7 plus 2, which is equal to f of square root of 9, because 7 plus 2 is 9. And then the square root of 9 is 3, so that's going to be f of 3. And now I'm going to do what f says finally. So f of 3, well, here's f. The rule is whatever it is, you're going to square it and take away 1. So if you have 3 there, I'm going to square 3 and take away 1. And so I get 9 minus 1, which is 8. Let's do this again, but instead of doing f composed with g, we'll do g composed with f. And this one's evaluated at 0. So write down what it says. Very important. Don't skip this step. So g of, and then comes f. So f of, and then comes 0. So f of 0. That's what it says. And now I'm just going to do what it says. So here I have f of 0. Here's f. The rule is you square it and take away 1. So I have g of, square it, 0 is my it, and take away 1, which is really g of negative 1. And now I'm going to do what this one says, g of negative 1. Well, g is just the rule. Whatever it is, you're going to add 2 to it and take the square root of all of it. So if I have a 1 here, or negative 1 here, it's going to be the square root of negative 1 plus 2, which simply equals the square root of 1, because negative 1 plus 2 is 1, and the square root of 1 is positive 1. And so that's how we handle composition when we're evaluating it at a point using two formulas. All right, so what we've done so far is we've taken a look at graphs, tables, and formulas and evaluating at a point. But now, instead of evaluating at a point, what we want to do is evaluate these at x. So we get a completely new function, not just a value. So we're going to use the formulas, define a formula for each function, and make sure to simplify. All right, so there are two formulas there, and it's really not that bad if you just write down what it says to do. So if you look here, this says f plus g of x. So what does that mean? That means take f of x and add g of x to it, just like you'd think. Just like you think it says, basically. So here, f of x is x squared minus 2, so I'm going to take x squared minus 2, and I'm going to add 3x minus 7. And so what do I get here? I get x squared plus 3x, and then minus 9, because I have minus 2 and minus 7, and that's my answer. So that's f plus g of x. Then f minus g of x, or f minus g of x, is equal to, Well, what it says is take f of x minus g of x. That's what it means. And now let's just do what it says. So you just write down f of x. So that's x squared minus 2. And then minus, now here's where you have to be careful, minus g of x. So this is all of g of x. So I need to put that into parentheses. So minus 3x minus 7. And then distribute that minus sign through. So I have x squared minus 2 minus a 3x. And then minus a minus is a plus 7. And so what's that equal to? That's equal to x squared minus 3x. So I just want to simplify now. And I have a minus 2 plus 7, which is really a plus 5. And so that's my new function. So notice, now I'm not getting out a number, I'm actually getting out a new function, hence, the algebra of functions. So that's addition, subtraction, and now we move on to multiplication and division. So multiplication, we have f times g of x, so that really means do f of x times g of x. And now we simply do what that says, and so you just copy down f of x, make sure you put it in parentheses because you're going to take x squared minus 2, and multiply the whole thing by g of x, which is 3x minus 7. And so here we need to simplify, so let's just multiply out. We can practice our factoring on here. So it's really easy to multiply this out. The idea is you just take x squared times this and x squared times that. So you're going to get 3x squared minus x squared times 7, so 7x squared. And then you take the next term and multiply by this, and then multiply by that. So minus 2 times 3x is minus 6x. Oh, and this is supposed to be a cube right here. Let's just fix that real fast. So that shouldn't be a square, that should be a cube. Because it's x squared times x. Alright, so where were we? So minus 2 times 3x is a negative 6x, and then negative 2 or minus 2 times minus 7 is a plus 14. And so that's f of x times g of x. And then finally, we come here to f divided by g of x. And so that's going to be equal to f of x on top divided by g of x on the bottom. And this one's actually very simple. So the idea is you just write down f on top. So here's f. So you have x squared minus 2 on top. And on the bottom you have g of x, which is 3x minus 7. And we're all done. It's f divided by g of x. And then finally we have these last two problems here. So let's do this one. So I'm going to rewrite this over here so we have some more space. So for part E, what we have is f composed with g of x. And I'm just going to do what it says. So remember, composition, the idea is you put a function inside another function. So here you have f of, and you write down g of x. And now I'm just going to do what that says. So wherever I see this g of x right here, I'm just going to replace it with its formula. So there's g of x, and it appears its formula. So I'm going to rewrite this as f of, and I'm going to write 3x minus 7 here, because that's what g of x is. And now I'm going to do what this says. And now what this says, you have to follow the rule for f. So the rule for f, whatever this is, you're going to square it and take away 2. So this is your new it. Let's use a different color here. This is my new it. I'm going to square it and take away 2. So square it, so 3x minus 7, quantity squared. And it says take away 2, so I take away 2. And then I have to do a little bit of algebra here. I need to square out the 3x minus 7. So up here, maybe I'll do that on the side so you can see how I'm thinking. So 3x minus 7 quantity squared just means 3x minus 7 times 3x minus 7. And again, you square it out. You can call this foiling, or this is really just a distributive property. I always use the arrows to help me keep track of things. So 3x times 3x is 9x squared. 3x times minus 7 is a negative 21x. Then take the next two terms, so negative 7 times 3x and negative 7 times negative 7. So I get minus another 21x. And then minus 7 times minus 7 is positive 49. And so what I get here is 9x squared. And then I have minus 21x, that's minus 42x. And then plus 49 and minus 2. And so my final answer would just be 9x squared minus 42x plus a 47. And so that's f composed with g of x. And then finally, we'll do one more here. Let's go the other way just to practice our composition. So f, so part f, we have g composed with f of x. And what that means is that g remains on the outside, so g of, and then write f of x a little bit smaller so it's real clear what's on the inside and outside. So that's on the inside, and g's on the outside, and then just do what it says. So look here. Here's my f of x. I'm just going to replace that with the formula. So here's the formula up here, x squared minus 2. And so that's g of an x squared minus 2. And now I'm just going to do what that one says. So I go up to g, and I see g is a rule. 3 times it minus 7. So this is sort of my new it. And so I'm going to take 3 times it and take away 7. So 3 times it, so 3 times x squared minus 2, and then take away 7. And so that's going to be equal to 3x squared. I'm just going to distribute that 3 through, so 3 times this and 3 times that. And so then 3 times minus 2, which is minus 6, and then minus a 7. And so that's going to be equal to 3x squared minus 13. All right, so that's how you do the algebra of functions when you're given just 2 formulas. The last example we want to do is we want to talk a little bit about how to build functions. So this is kind of important, especially when we get to calculus. It turns out that most of the functions that we work with in calculus are called elementary functions. And these are functions that are made out of power functions, which are just basically x to a power. Exponential functions, which you might be familiar with, like 2 to the x or e to the x. Logarithmic functions, so one of the most common ones is just log x, or one of my favorites, ln of x. And then the trigonometric functions, which we'll talk a lot about later, just stuff like sine of x, or cosine of x, or tan of x. So most of the functions we work with are made from one of these 4 types of functions, and the way we make new functions is we sort of add, subtract, multiply, divide them, and then also compose them, composition. So we want to kind of get good at sort of building functions out of these types of functions with these sort of operations. So that's really the point of the next example that we're going to do. So what we want to do here is we want to use f, g, and h to build each function using addition, subtraction, multiplication, division, and composition. So this takes a little bit of practice, but it's really not that hard in the end. So the idea is here's a function right here, a of x, x to the 11th plus x to the 5th minus 3. And then you look above here and you see that basically this function is made up of these functions with these various operations. And in fact, you can even write here, this is f, this is g, and this is h. And so this is really equal to, if you want, we can just rewrite this as h of x, because that's x to the 11th, plus, not h of x, but f of x, right? So that's f of x, that's where we start. That's your x to the 11th. And then you're adding the h, right? So h of x. And then you're taking away 3, which is the same thing as g of x. And then we can rewrite this even further, sort of using this functional notation idea of just saying, hey, this is f plus h minus g, and that's all evaluated at x. So that's how we can rewrite this function in terms of these sort of other functions, f, g, and h. So this was an example involving addition and subtraction. Now down here, what you notice is going to be a little bit harder, but if you think about it, it's really not that bad. So here we have b of x, which is x to the 5th plus 3, and that's all raised here to this 11th power. So what you can see is x to the 5th, so we'll kind of start slow, that's an h, and then plus, and of course the 3 is the g. So if you like, you could actually write this as left parenthesis h of x plus g of x all to the 11th power. And now here's where you have to think kind of outside or inside of the box, depending on how you think about it. On this problem, you have an inside and you have an outside. And that's where we get this sort of idea of composition. A function inside of a function. And of course the function, the outside function is to the 11th power, and the inside function is h of x plus g of x. So what we can do is we can actually rewrite this if you want, that to the 11th power is really the x to the 11th. So we can rewrite this as f of h of x plus g of x. And then we could even go one step further if you like and rewrite this as f composed with h plus g of x. And that one's a little bit tricky, but the point is, what you need to see is that basically this function here is made up of three sort of simpler functions using these operations of addition, subtraction, multiplication, division, and composition. All right, so let's do a little bit of a recap here. All right, so we have sort of this idea of algebra of functions, and what that is you adding, subtracting, multiplying, dividing, and composing functions. Now, if we do this, all the time, you never really think about it. Companies, they have employees. Employees have salaries, so you add all the salaries, you get a total salary. So it's an addition of functions. Multiply, division, and composition, the same things. There are lots of examples of these. You can do them with tables, graphs, or even formulas. You can evaluate them at a point, or you can find a completely new function. And then finally, at the end of the day, what we're trying to do is figure out how to build functions from sort of simpler functions. And so we'll see, how do we make these elementary functions? We basically build them out of these power, exponential, logarithmic, and trigonometric functions. And you'll see that basically we spend the next chapter kind of studying, in essence, power functions, and then we spend another chapter on exponential and logarithmic functions, and sort of a final chapter on trigonometric functions, and that completes, basically the basic elementary functions, which are used to model most things in calculus.